Good afternoon, dear students. The lesson that I'm going to do this afternoon is for class 7. The subject that dear students know very well, it's geography. So the chapter that I'm going to cover today is the atmospheric pressure. So before I start this lesson, dear students, I would like to request you all to please have a small writing note sheet in front of you. Keep your pencils ready as well as your textbooks open so that as I go on teaching this chapter, you may refer the book so that it becomes much more easier for you to follow as I teach. So the chapter right now we are doing is the atmospheric pressure. So what is atmospheric pressure, dear students? Yeah, in a very, very simple term, atmospheric pressure means the force of the air. If you say atmosphere, what is the atmosphere comprised of? It's comprised of air. We have different types of air. It could be carbon dioxide, it could be oxygen, it could be helium, it could be argon, nitrogen. We have different types of air in the environment. So this air, when it applies its force on the Earth's surface, it is termed as the atmospheric pressure. So if you want to define what is atmospheric pressure, we can state that atmospheric pressure can be defined as the column of air can be defined as the force exerted by the column of the air on the Earth's surface. So once again I'm going to say, dear students, atmospheric pressure can be defined as the force exerted by the column of the air on the Earth's surface. That is the atmospheric pressure. Now, the atmospheric pressure, as I told you, is measured by an instrument called the barometer. The atmospheric pressure is measured by the instrument called the barometer. Now, the atmospheric pressure is not the same all over the world. It varies from place to place. And we'll be studying in the later course of this class why the atmospheric pressure varies from place to place. It's not the same. The atmospheric pressure in the plains is different compared to the atmospheric pressure in the hills. The atmospheric pressure from one region varies from the other region. There are various factors which we'll be studying in the later course of this class. So, the atmospheric pressure, as I told you, is defined as the force exerted by the air, column of the air, exerted by the air on the Earth's surface. So once again I'm going to say, atmospheric pressure is defined as the force exerted by the air on the Earth's surface. Now, the atmospheric pressure is measured by an instrument called the barometer. Now we have different types of barometer. For instance, we have, if you see here,
was it barometer?
See.
2 times. No.
So you can see it. Now we have a barometer here, we have a Mercury Barometer, and then we have an aneroid barometer. Now besides these two barometers which measure the atmospheric pressure, we also have other instruments which measure the atmospheric pressure. For instance, you can also name an instrument called the altimeter. The altimeter, A-L-T-I-M-E-T-E-R, altimeter. The altimeter is an instrument which measures the height. It's mostly used in the aeroplanes. You have this device installed in the aeroplanes. As you go higher up, it records the altitude. So therefore, altimeter is an instrument which measures the height or the altitude as you move in an aeroplane. Then we also have another instrument called the Fortin's barometer. F-O-R-T-E-I-N-S, Fortin's barometer. Now this Fortin's barometer is also an instrument which measures the atmospheric pressure. But this instrument is installed in a meteorological station. It's installed in a meteorological station, weather station, so that you can record the atmospheric pressure. But then we focus mostly in the two instruments, that is the Mercury Barometer and the aneroid barometer, because this is what your syllabus is all about. The two instruments, that is the Mercury Barometer and the Aneroid Barometer. Okay, so dear students, please keep that in mind. Once again, I'm going to say, now we have the instruments that measures the atmospheric pressure. I told you we have the Mercury Barometer, we have the Aneroid Barometer, then we also have the Altimeter, and we also have the Fortin's Barometer. Now, among these four, we are going to focus on these two, because this is what is in your syllabus. That is the Mercury Barometer and the Aneroid Barometer. So, the first one here we have is the Mercury Barometer. Now, this Mercury Barometer is an instrument which measures the atmospheric pressure. You can see here. It is an instrument which measures the atmospheric pressure. It's very accurate. But then what happens is, this instrument is not used as much as the Aneroid Barometer. The Mercury Barometer here is a very accurate instrument which measures the atmospheric pressure. But this is not used as much as the Aneroid Barometer. So, we can see here, the Mercury Barometer is basically a U-tube which is inverted into a bowl of mercury. We have seen mercury installed inside this tube. And then we have some space, we have some air there, which allows the mercury to expand and contract according to the change in the temperature. Okay, so now we have this instrument here, the Mercury Barometer. I will go to the front here. And now let's see. I told you this Mercury Barometer is a very accurate barometer, but then what happens is, this barometer is not used always. The reason why it's not used always is because of some disadvantage. You can see here. See? The Mercury Barometer is not used as much as the Aneroid Barometer. And why is that? Dear students, there are some difficulties. The first one here is that the Mercury Barometer is very fragile, very delicate. Why is it fragile? Because it has a U-tube, see, glass tube, which is inverted into a bowl of mercury. Very fragile. It can break. If it topples down and falls on the ground, it breaks into pieces. So it's very, very fragile. Then another thing is that it's very difficult to transport. See, it's inverted into a bowl of mercury, a container of mercury. So as you move, the mercury is bound to move. And as the mercury moves in the container here, it's obviously going to show a wrong reading. Therefore, you can't take it from one place to another. It has to be installed, fixed in a place. Then yes, you can get the reading of the atmospheric pressure. But then if you want to take it from one place to another, it is not possible. Firstly, because it's very fragile. Secondly, because it's difficult to transport. And thirdly, because it is rather very toxic. Now the next one is the Aneroid Barometer. This is the Aneroid Barometer. See? It's very small. It works on the basis of the air pressure. There's a vacuum inside this instrument. So when the pressure is applied on this instrument, the readings are shown. Higher the pressure, more the readings. This arrow marker starts to increase as the pressure is more, and if the pressure is less, then the arrow or the marker starts to decrease. So more the pressure, more this arrow moves, more the arrow moves. And then when the pressure is less, the arrow starts to fall back. So this is the Aneroid Barometer, which is used all over the world. And the reason why it's used all over the world is because firstly, it is very, very small. See, it's a very small device. It's not a very big device. Number one, it's transportable. You can take it anywhere. See, very handy. Another reason it's very handy because you can take it anywhere. Another one is that you can carry it and take it anywhere. See, you can carry it and take it anywhere. The first one I told you is very small, very portable. You can take it anywhere. And the second one is you can take it anywhere because there is no mercury in this. It works on the basis of the vacuum, the air pressure, because there's vacuum inside. So it works on the basis of the air pressure. So therefore you can take it anywhere. So this is the advantage. This is the advantage of the aneroid barometer. So I told you the Mercury barometer, the first one, it's very accurate, but you can't take it. It's because it has mercury, and therefore you can't take it from one place to another. Now, moving a little bit ahead. Now, as I told you, what is atmospheric pressure? Atmospheric pressure is the force exerted by the column of the air on the Earth's surface. It is measured by an instrument called the barometer. Now, there are different types of barometer. We have the Mercury barometer, we have the aneroid barometer, we have the altimeter, and we have the 14th barometer. The Mercury barometer, I explained to you, it's very accurate, but then what happens is that it has some disadvantage. You cannot take it from one place to another. It is very fragile, it is very toxic. But then the aneroid barometer is very handy. It's very small, and you can take it from one place to another. And that is the reason why the aneroid barometer is used in most of the places and most of the times. And then I told you we have the altimeter, which is used to measure the height of a place. It's mostly installed in the aeroplanes. And then we have the 14th barometer, which is installed in the meteorological stations or the weather stations to record the atmospheric pressure. Then we also have an instrument which records the atmospheric pressure by itself. That is called as the barograph. What is a barograph? A barograph is a self-recording instrument which records the atmospheric pressure by itself. Dear students, please keep that in mind. The barograph is an instrument which records the atmospheric pressure by itself. A self-recording instrument which records the atmospheric pressure by itself. That is called the barograph. So I've told you what is an atmospheric pressure. I've told you it's measured by an instrument called the barometer. I've told you there are different types of barometer, like we have the Mercury barometer, the aneroid barometer, the altimeter, and the 14th barometer. Then I also told you that we have a barograph, an instrument called the barograph, which records the atmospheric pressure by itself. Now we use different scales to measure the atmospheric pressure in the instruments. Whether it's a Mercury barometer, whether it's an aneroid barometer. So most of the time we use the scale that is called the millibars to record the atmospheric pressure. Millibars is the scale used to record the atmospheric pressure. Millibars. The short form of this is MB, millibars. But we also measure in millimeters, if you want to measure in the atmospheric pressure. Okay, and then we go to the next part, and that is the isobars. Now I told you, the place all over the world do not have the same atmospheric pressure. Different places have different atmospheric pressure. It's not the same. Some places the pressure is higher, some places the pressure is low. But again, there are some different areas where the pressure is the same. Like for instance, the pressure in Sikkim, and the pressure in, say, if you go to Punjab, or if you go to Mizoram, or if you go to, say, Nagaland, the pressure in these areas could be the same. So how do we locate the places having the same atmospheric pressure on the map? Suppose we have a map of India, and if I want to show the different places which have the same atmospheric pressure, how do I project that? How do I show that? So in order to show that, dear students, we use the isobars. We take the help of the isobars. Now, what is an isobar? An isobar is an imaginary line. It's an imaginary line. Once again, I'm saying this, dear students, please pay attention. Please don't get restless as we are teaching. Please be attentive. And as far as possible, please have your textbooks open in front of you so that as I teach, you can listen very carefully. And after I have taught whatever videos have been uploaded in the YouTube, you can just go through that a number of times, couple of times, and then you come to know so many things. I think this is one of the advantages of recording having this recorded and then uploaded in the YouTubes because you can listen to it a number of times. So that many of your doubts are cleared. So please pay attention, okay? So as I was saying, what is an isobar? So if I want to show different places like Sikkim, Punjab, Nagaland, Arunachal, suppose if they have the same atmospheric pressure. Now it goes on changing, but suppose they have the same atmospheric pressure in a particular time, at a particular time. So how do I show that on the map of India? So I show that on the map of India with the help of a line that is called as the Isobars, which I would once again like to state that an isobar is an imaginary line which joins places having the same atmospheric pressure. Once again I would like to say, isobars are imaginary lines which joins places having the same atmospheric pressure. So I've told you what is an atmospheric pressure. It is the force of the air exerted on the Earth's surface, the instrument that is used to measure it, the different types of instruments that are used to measure atmospheric pressure, what is a barograph, what is an isobar, the scales that are used in measuring atmospheric pressure like millibars, MB, or millimeters. Now, we come to the next lesson, that is the factors which affect the atmospheric pressure. Now I told you, the atmospheric pressure is not the same. It's not the same all over the world. It goes on changing. I told you in the beginning of this class that we'll be discussing in the later course of this class here. Why does the atmospheric pressure go on changing? See? The atmospheric pressure is not the same all over the world. The atmospheric pressure gets lesser and lesser. Why does it happen? Would you like to think for some time? Why does the atmospheric pressure change from place to place? Or why is the atmospheric pressure more at the sea level and less at the mountains? It is because of the amount of air that is there in a particular area. If there is more air in a particular region, there will be more pressure. If there is less air in a particular region, there will be less pressure. So as we go up the mountain, what happens? The air becomes lesser, lesser and lesser. And that is the reason why the mountaineers, when they climb Mount Everest or different mountains, what happens? They use oxygen. They take some oxygen cylinders. So that what happens? They can inhale the air as they go up the mountain. It's because the air becomes lesser and lesser as you go up the mountain. So now, I've told you the factors. What are the factors which affect the atmospheric pressure? Now there are different factors. The first one is temperature. Temperature is the first factor which affects the atmospheric pressure. Now how does the temperature affect the atmospheric pressure? How does it affect? For instance, if you go to the plains, what happens? The sun shines, it's much more warmer. It's much more warmer compared to the mountains. So when the sun shines, what happens? The air gets heated. The air gets heated. And the air starts to rise. The temperature in the plains are much more compared to the mountains. So therefore, when the sun shines and because the heat is much more in the plains compared to the mountains, what happens is, when the sun shines, the air gets heated up. The warm air then starts to rise up. At that particular time, what happens? They experience a low pressure. Because the air is less, the air starts to rise up, evaporate. And that region experiences a low pressure. Similarly, if you go to the mountains, what happens? The air gets very cold. And as the air gets very cold, what happens? The air becomes heavy. And this heavy air starts to sink down. And as the heavy air starts to sink down, what happens? It exerts pressure. It exerts more pressure, whereby creating a high pressure. See, this is how the temperature affects the atmospheric pressure. When the sun shines in a particular region with great intensity, makes it very hot. The warm air starts to rise up, and at that time, what happens? The pressure exerted is less in that region. But again, if you go to the mountains where it's very cold, the air is very cold and heavy and starts to sink down, creating more pressure. And therefore, the pressure will be high if you go in the mountains. That is temperature. Number 2 is altitude. Altitude is also another factor. Altitude is also another factor which affects the atmospheric pressure. Okay, the students? Altitude is also another factor which affects the atmospheric pressure. How does the altitude affect the atmospheric pressure? See, if you're in the plains, as I told you in the beginning, see, coastal areas. The coastal areas have more pressure. They experience a higher pressure because there's more air there. There's more air there in the coastal regions. Because all the cold air moves to the warmer regions. And as this air moves to the warmer regions, there's bound to be a lot of air in the warmer regions, because of which it exerts a lot of pressure, and therefore they have high pressure, which is experienced in the warm region. But then as you go higher up the mountain, altitude, see, as you go higher and higher up the mountain, the air becomes lesser and lesser. And I told you that's the reason why they use oxygen cylinders. See, that's the reason why they use oxygen cylinders, because there's very less air. So when there's less air, there is bound to be less pressure. Because there's less air in the mountains, there is definitely going to be less air. And if there's less air in the mountains, there will be less pressure. So that is how the altitude also affects the atmospheric pressure. See, I told you temperature. Warmer regions experience more temperature. So therefore what happens? They experience a low pressure. Cold regions are very cold, and therefore they experience high pressure. Now if you go to the next point, that's altitude. See, if you're in the plains, more air comes to the plains. And therefore what happens? There will be what? Higher pressure. More pressure is being felt there, because there's more air in the plains. But as you go up the mountains, what happens? The air becomes thinner and thinner, lesser and lesser, and therefore they will exert less pressure. That is how the altitude also affects the atmospheric pressure. Now the third one is the unequal heating of the Earth's atmosphere. Unequal heating of the Earth's atmosphere. See, you know the Earth is round. See, oblate spheroid. It's not exactly round. It's bulging at the sides and flat on the top and bottom. See? Flat at the top and bottom and bulging at the side. So, because of the unequal heating of the Earth's surface, what happens? There is different atmospheric pressure being experienced. So the third factor which affects the atmospheric pressure is the unequal heating of the Earth's atmosphere. If you go to the equator, there the sun shines more. And because the sun shines more, the air gets warmer in that region. And when the air gets warmer in that region, what happens? The air starts to rise up. The air starts to rise up. Therefore, creating an area of low pressure. But again, if you go to the poles, very cold place. If you go to the poles, what happens here? Okay, I'll give you a small this one here. Here, see? You can see here. Here, see? Suppose the sun shines from here. Here. See? When the sun shines here, this is the Equatorial Region. This is the Equatorial Region. Now here what happens is the sun shines with greater heat, and therefore this region becomes warm. And when this region becomes warm, this air starts to rise up into the sky, and therefore it creates a low pressure area. But again, this space comes just here, this area, see? See, it's very far. This space is closer to the sun, but this space is far. So therefore, it receives less amount of heat compared to the equator. it receives less amount of heat compared to the equator because the equator is closer to the sun. Whereas the poles, North Pole, places they are 60 degrees, 70 degrees, 80 degrees, they are away from the sun because of the shape of the earth. See, it's round. If it was flat, yes, there would not be much difference. But because the earth is spherical in shape, the areas which are near the equator have more heat than the places which are away from the equator. So therefore, the places which are away from the equator, like the northern region and the southern region, these areas, they receive less amount of heat, and therefore what happens is colder. And because it's colder, what happens is they experience a high pressure. And then the fourth factor which affects the atmospheric pressure is the rotation of the earth. We all know that the earth rotates from west to east. The fourth factor which affects the atmospheric pressure is the rotation of the earth. Now, how does the rotation of the earth also cause a change in the atmospheric pressure? Now, if you see here, so when the earth rotates from west to east, what happens is the air also is pushed either towards the poles or towards the equator. And that is mostly experienced in the regions in the 60 to 65 degrees north and 60 to 65 degrees south. In this belt, 60 degrees north to 60 degrees north, 65 degrees north, and 60 degrees south to 65 degrees south, what happens is the air is pushed. The air is pushed out, either towards the North Pole, either towards the equator. Again, from here, either towards the equator or towards the South Pole. And therefore, what happens? They experience a low pressure here. Because there's less air. Why is there less air? Because of the rotation, the air is constantly pushed towards this region here. From here also, because of the rotation, the air is constantly pushed towards the South Pole. If you see in the northern part also, because of the rotation of the earth, the air is constantly pushed from this region, from 60 to 65 degrees north, there is constantly pushed towards the subtropical high pressure belt, that is also constantly pushed towards the North Pole. See, as the earth rotates, there is pushed out, and therefore they experience a low pressure. So this is how the rotation also affects the atmospheric pressure. Because the earth rotates in certain regions, there is pushed out. It's pushed out. And when the air is pushed out from this region towards this side, there will be less air here. And because of which they experience a low pressure. Same thing in the north and same thing in the south. So once again, dear students, I'll just recapitulate. Here, I told you what is atmospheric pressure. Atmospheric pressure is the force exerted by the column of the air on the Earth's surface. It's measured by an instrument called the barometer. There are 4 types of barometer. Then Mercury aneroid, altimeter, and Fortin's barometer. There is a scale I told you we measure in millibars or MB or millimeters. Then I told you about the barograph, which is an instrument which records the atmospheric pressure by itself. Then I told you what is an isobar. It's an imaginary line which measures pressure, measures places having the same amount of, it joins places having the same amount of atmospheric pressure. Then the factors which affect the atmospheric pressure. I told you temperature is one factor which causes a change in the atmospheric pressure from one place to another. Altitude is another factor which causes a change in the atmospheric pressure from one place to another. Then the unequal heating of the Earth's atmosphere because of the shape of the Earth. Because of the shape of the Earth, what happens? Different places have received different amount of heat, because of which the atmospheric pressure also changes. And then we go to the next one, that is the last one, that is the rotation. Rotation is also another factor which creates a change in the atmospheric pressure. Now let's look at the book, dear students. The effects of air pressure. What are the effects of air pressure? Because of the air pressure, what happens? Now, the first one is that, see, I told you, in the warm region, if you go to the warm region, the air is warm, and therefore it's light and it starts to rise up. So therefore, it starts to move up. This is in the warm regions where they experience low pressure. The places where it's warm experience a low pressure because the air starts to rise up. And then again, in the places where it's very cold, the air is very cold and heavy. and therefore it starts to sink down. Therefore, it experiences a high pressure. See? Because the air is warm, it starts to rise up, and as the air rises up, there is less air, there is less pressure, because of which what happens? They experience a low pressure. And again, when the air is very cold, especially in the mountains, where it's very cold, the cold air is very heavy, dense and heavy. Dry, they are also very dry, there's no moisture, and they start to sink down. And when they start to sink down, they apply pressure on the land, which creates a high pressure. So, when the air rises up and down, it is called as air current. The vertical movement of air upwards or downwards is called as the air current. And this is very important for the change in the weather condition. See, it plays a very, very important role. Now, when the warm air rises up, because the warm air is full of moisture, and that's how we get rainfall. If this warm air, which is light, rises up, it has a lot of moisture, because of which we have rainfall. And after the rain is all released from the air, it becomes cold and heavy, and then they start to sink down, whereby creating a high pressure. So the vertical movement of the air upwards or downwards is called as the air current. Now, along with air, when this air current takes place, now it creates what? It creates wind. See, when the warm air rises up, how is it going to come down? Or how does the warm air from the plains, from the sea which has risen up, how does it come here? It comes because of the plains. It comes because of the wind. The wind blows the air, and that is how we get rainfall here. See, during the month of June, when we have the southwest monsoons coming. See, June, July, August, September. That is the time when we have a lot of rainfall. From where did this rainfall come? This rainfall came from the Indian Ocean. But there the warm air rises, just rose up. The warm air from the ocean just evaporated and went high in the air. It started to rise up. But how did it come to Sikkim? How did the rain come to Sikkim? It came with the help of wind. The wind blew the air here. Again, after the air has given all the rainfall, it sinks down. After it has sunk down, again the cold air moves to the warm areas. It moves to the warm areas, whereby creating wind. So with the help of the air currents and the wind, we have a circulation of the air taking place in the environment. See? Warm air rising, cold air sinking, and that is how we have the water cycle taking place. See? And that is how we have rainfall. It's very, very important. So the effects of the air pressure. What happens because of the difference in the air pressure? Because of the difference in the air pressure, we have what is called as wind being formed. Wind is created. See? Because of the air currents, warm air rising, cold air sinking, what do we have? What does it create? It creates wind. And because of the vertical movement and the wind, because of the air rising and sinking, and because of the help of the wind, we have a circulation of the air taking place in the environment, whereby creating water cycle, whereby creating movement of the air up and down. And that is how we have different weather conditions being experienced all over the world. It's because of the air current and the wind. Okay, now let's go a little bit now further and let's see the different pressure belts of the world. Let's see the pressure belts of the earth. Pressure belts of the earth. Now this is a diagram which I have just drawn here. This is the pressure belts of the earth. Pressure belts. See, pressure belts. This is the pressure belt. That means because of the difference in the pressure, because the atmospheric pressure is not same all over the world, different places experience different pressure. See, different pressures experience all over the world. The pressure is not the same. And I told you why it's not the same. It's because of the temperature, it's because of the altitude, it's because of unequal heating of the Earth's atmosphere, it's because of the rotation, which creates different pressure over different regions over the world. Now the first one which we will do is the Equatorial Low Pressure Belt. See this one here? Equatorial Low Pressure, I'm going to write in short form. Okay? Equatorial Low Pressure Belt. Equatorial Low Pressure Belt. Here, equatorial, see, equatorial low pressure belt. That means it's found in the equator. See, this is 0 degrees. I'll make it a little thicker for you. If you want the equator to be seen, I'm going to make it a little thicker for you. Here, see, this is the equator. 0 degrees. Now, the equatorial low pressure belt is experienced in the region from 5 degrees north to 5 degrees south, this area. 5 degrees north of the equator and 5 degrees south of the equator, we experience the equatorial low pressure belt. Now, why do we experience a low pressure belt here? Why do we experience a low pressure? I told you, it's because of temperature. See, the equator is a region where it's the hottest. When the sun shines, this region becomes hottest, we all know. The equatorial region is the hottest region in the world. It's because it receives vertical rays of the sun, because of which it's very, very hot. And because it's very hot, the warm air starts to rise up. See? The warm air starts to rise up. It starts to rise up. See, it starts to rise up. The warm air starts to rise up this way. It rises up. And as the warm air starts to rise up, it experiences a low pressure. That is why it is called as the equatorial low pressure belt. There is a lot of vertical movement of the air only. The warm air starts to rise up constantly because it's very warm in this region, because of which it experiences a low pressure. There is practically very less horizontal movement of air taking place. Very less wind blows in this region. Very less wind. Wind is straight. See? Horizontal movement of the air is called as wind. Very less wind takes place in this region. Therefore, it's also called as the doldrums. Doldrums. D-O-L-D-R-U-M-S. Doldrums. Because there's very less horizontal movement of the air taking place in this region. This is the first belt, equatorial low pressure belt. It is from 5 degrees north to 5 degrees south. Equatorial low pressure belt. And I told you why it experiences a low pressure belt. Why it experiences low pressure is because of the temperature. High temperature is experienced in this region. And because it's very hot here, the warm air starts to rise constantly, because of which it creates a low pressure. The first one. See, the warm air rises up constantly. Okay, I'll just erase this one. The pressure belts, okay? Because I may have to do some. Here, see, warm air rises up. Now the second pressure belt. The second pressure belt which we have is called the subtropical high pressure belt. Here, this region, from 30 to 35 degrees north. 30 to 35 degrees north, subtropical high pressure belt. See, 30 to 35 degrees north, we have the subtropical high pressure belt. It experiences high pressure. Even in the south of it, you can see, from 30 degrees south to 35 degrees south, we have the same thing here. Subtropical high pressure belt. See? You can see in the north also we have the subtropical high pressure belt from 30 to 35 degrees north and 30 to 35 degrees south. They experience a high pressure. Now, how do these regions experience a high pressure? See, as I told you, because the air from this region starts to rise up from the equator, see, the warm air goes on rising up this way, and as the warm air starts to rise up, where does it go? The warm air, it moves to the colder areas. See? Or you have to always keep in mind, see, the warm air always moves from a low pressure area to a high pressure area. See, wind always blows. Wind always blows from a low pressure area to a high pressure. Here we have the vertical movement of air to be. That means in the warm air regions, the warm air starts to rise up. In the cold places, the air starts to sink, therefore creating a high pressure. Now here again, coming back here again. See, when the warm air from the equator starts to rise up, it moves to the colder regions. The air will always move to the colder place. See, from the warmer place, the air always moves to the colder place. So after the air has risen up from the equator, it moves towards the poles. And as it goes to the poles, it gets colder and colder and it starts to sink here. See, from here it rises up, it moves to the poles, sinks here. From here the air rises up, warm air rises up, moves to the poles and sinks here. Same thing happens from here. The warm air will rise up, it becomes cold, it moves to the poles and it sinks in this region. From here it rises and sinks here. So therefore, when more and more of the air is sinking in this region, the air becomes heavier and heavier. When more and more air goes on, continuously goes on sinking in this region experiences a high pressure. Therefore, it's called as the subtropical high pressure belt in the north and subtropical high pressure belt in the south. Because it's near the tropics. Therefore, it's called as the subtropical high pressure belt. Why high pressure belt? Because it exerts a lot of pressure. A lot of air starts to descend here. And because when there's more and more air descending in this region, in the north and in the south, what happens is there is bound to be more pressure, because of which it experiences a high. Okay, so we continue with the lesson here. This is the Equatorial Low Pressure belt. I told you why it's the low pressure, because of the temperature which makes the air constantly rise up, and therefore then it experiences a low pressure. Now when this air from here rises up, it moves towards 30 to 35 degrees north and 30 to 35 degrees south. It moves up, it rises up, and then it moves to the colder place. It's always like that. The air, warm air will always move from the warmer place to the colder place. From low pressure area to the high pressure area it moves. So here also, when the warm air rises up, it moves to the colder areas. So it moves to the north and south. And then it comes to the region 30 to 35 degrees north and 30 to 35 degrees south. And therefore it starts to sink here. See, warm air will rise up and sink here. The warm air rises and sink here. See, here also the warm air will rise up and sinks here. The warm air will rise up and sink here. So when the warm air constantly rises from here and sinks here, there is more and more air pressure here, because more and more cold air is sinking here. When more and more cold air goes on sinking here, it experiences a high pressure. Therefore it's called as the subtropical high pressure belt in the north and subtropical high pressure belt in the south. North and south. It's also called as the Hauss latitude. See, it's also called as the Hauss latitude. The reason why it's called as the Hauss latitude is because in the old Indian time, when the ships carrying horses moved through this region, the ships could not move ahead. Because in this region, like the doldrums, where there's no movement of wind taking place, practically very less wind blows in the doldrums. That's why it's called as the doldrums. Here also, similarly, very less air blows in this region. Wind blows in this region. And like I was telling you, in the olden days, as the ship carrying horses were moving through this region, the ships were so heavy with the load of the horses, besides the load of the ration that is there, the load of the people that are there, the sailors that are there. In spite of that, it was so heavy that the captain of the ship was compelled to throw all the horses into the sea. And therefore, this region was called as the Hauss latitude. 30 to 35 degrees north and 30 to 35 degrees south. Then if you go further up, we have the 60 degrees north and 65 degrees north and 60 degrees south to 65 degrees south. This place is called as the subpolar low pressure belt in the north, and we also have here, see, subpolar low pressure belt. See, that is here they experience a low pressure. It's in the subpolar region, 60 to 65 degrees north and 60 to 65 degrees south. They experience a low pressure. That is in the subpolar region. So therefore, this region has low pressure. Why does this region here between 60 to 65 degrees north and 60 to 65 degrees south experience a low pressure? It's because of the rotation. As the earth rotates, I told you, because of the rotation of the air from this region is flung towards the north and towards the south, towards this region, 30 to 35 degrees north. From here also, as the earth rotates, from this belt, the air is pushed towards this side, towards the subtropical high pressure belt, towards this region. That is why they experience high pressure here. Because from here, besides the air coming and sinking here, from here also air goes and sinks here. That is why they have high pressure. Now, how does this have a low pressure? Because the rotation of the earth, the air from this region is flung towards the north and south. And as they are pushed towards the north and south, they have less air, because of which they experience a low pressure. And therefore they are called as the subpolar low pressure belt. Here is the same thing. Because of the rotation of the earth, the air is pushed towards the north and pushed towards the south. Because of which they experience a low pressure. And therefore they are also called as the subpolar low pressure belt in the north. So we can see here it has low pressure, this too has high pressure. Again, this place has low pressure, this too has low pressure. Now coming to the last one, the north here. See, 90 degrees north and 90 degrees south. 90 degrees north and 90 degrees south. Here we have, in the North Pole, we have polar high pressure belt. See, in south also. See, South Pole, polar high pressure belt. That means here they experience high pressure in the north, and in the south they experience high pressure. See, because from here I told you, the air is pushed, because of the rotation of the earth, the air is pushed towards the south pole. So when more and more air is pushed here, they exert more and more pressure, creating a high pressure. Because here it's very cold, so air will go on sinking here and create a high pressure. Similarly here also, when the earth rotates, from here the air is pushed to the north pole, continuously. And because the space is very cold, the cold air goes on sinking, whereby exerting pressure and creating a high pressure. This is called as the polar high pressure belt in the north and polar high pressure belt in the south. So, dear students, these are the pressure belts. These are the pressure belts which are there all over the world. We have the Equatorial Low Pressure belt from 5 degrees north to 5 degrees south. Subtropical high pressure belt in the north from 30 to 35 degrees north and 30 to 35 degrees south. High pressure belt. Then we have low pressure belt here, 60 degrees north to 65 degrees north. Subpolar low pressure belt. They have low pressure here. In the south also, in the subpolar region from 60 to 65 degrees south, they have low pressure. Less air is there. And then lastly, in the North Pole and the South Pole, we have also high pressure. Because it's very cold, because of which it exerts more pressure and therefore they experience a high pressure. So these are the pressure belts that are there all over the world. So coming to the next class, we'll talk about wind. We'll discuss about the winds. And that also is very important. Along with the pressure belts, these pressure belts create wind. Because of these pressure belts, winds are created. We'll use the same diagram, and here we'll have to explain how winds are formed. Which side do they blow? What are the different types of winds that take place? That's what we're going to do in the next class. So till today or to this class, this is all I have to teach dear students. And I hope you'll go over this class in your mobile phones or in your laptops or in your tabs. You can just go through it a couple of times in YouTube. If you go on doing it a couple of times in YouTube, you'll come to understand much more as you go on doing it. So for your homework assignment, dear students, I would like you all to draw the Mercury Barometer. I don't think it's there in the copy. Mercury Barometer. Please draw the Aneroid Barometer. And also draw the pressure belts of the world. The pressure belts of the world. Don't mark the winds today. Just draw only the pressure belts. Winds we'll do in the next class. So on that same diagram, you can just add the different types of winds. So for your home assignment, you draw the diagram of the Mercury Barometer, which may not be there. You can just look and search in the Google. Mercury Barometer. Please draw the Aneroid Barometer and draw the pressure belts. And then you can just go at the back and see some of the questions which are there related with this chapter, which are there related with this portion, the atmospheric pressure, and just try to solve it. Okay, so this is the end of my class, dear students. Please stay safe, stay healthy, do wash your hands constantly, avoid touching your face every now and then, and stay home, stay safe, study well, and listen to your parents and be good at home as well. So this much for this class, dear students. Take care. Thank you so much.